Welcome to section 8.4 class. Today we're going to talk about rational expressions as a whole. Now, up to this point we've been talking about how to graph them. Now we're going to move on from the graphing idea. We're going to talk about how to apply properties and operations to them. So today we're focusing on two things. We're focusing on how can we simplify these and how can we multiply them together. Now the simplifying is something you've already basically been doing, okay? Because when I had you graphing them in the last notes, again, you had to simplify them to see if there was a whole or a vertical asymptote. So when we're talking about this, there's two main strategies to simplifying them. We're talking about either using rules of exponents or factor cancel. Now, either way, no matter what, in both instances, you are going to have to state restrictions as well. So just to show you how this works, so simplifying and stating the restrictions. I want to do my simplifying piece in blue to help you keep straight what I'm answering. So just rules of exponents. Now this happens when you have monomial expressions, all right? So this means no addition, no subtraction, just pure multiplication. So all you have to do, rules of exponents. So 24 divided by -6, well, that's going to give you a -4. X to the third divided by x squared. 3 take away 1. Remember, you subtract when you're dividing. 3 take away 1 leaves you 1. Now for the y's, y squared divided by y to the third. Well, 2 minus 3 leaves you a -1. All right, but remember, when you have a negative exponent, that'll just plop it down on the bottom. It ends up wherever there were more to begin with. Now, stating the restrictions. Now, stating the restrictions, again, when it looks like this and you're just applying rules of exponents, is actually really easy. The restrictions are just your variables can't be 0. Because if you think about it, if all you have is a chain of multiplication in the denominator, well, if you use 0, it's going to make the entire thing 0. End of story. Can't use it. So again, make sure that you realize when all you have is a chain of multiplication, a monomial, just say, hey, my variables can't be 0. Now do realize I used the original denominator when I made the excluded values. Okay? That is very critical to understand. I went back to the original denominator to do this. The other piece, sorry, I'm going to be doing restrictions in green. The other piece of this is factor cancel. Now, what I mean by factor cancel is, let's look at this. So the top, x squared plus 7x plus 10. I can factor that to x plus 2, x plus 5. And the bottom, x squared minus 3x minus 10, that's going to be x minus 5, x plus 2. So I factor it and then cancel anything that's the same. And I'm left with that as my simplified expression. All right, so that's the power of when you have to factor, is I just call it a factor cancel strategy, all right? Factor and then cancel anything that's the same. Now for the restrictions though, for the restrictions, remember you go back to the original denominator and set both pieces, saying, hey, neither one of these can be 0. So my two restrictions are x can't be 5 and x can't be -2. Okay? Recall, you have to go back to the original denominator because if you don't, you're going to miss some of your excluded values. So, just for a little more practice, on the top, x squared plus 2x minus 8, well, that is going to be x plus 4, x minus 2. Then on the bottom, to get that, we're going to have x minus 2, x minus 3. Be careful with that bottom one. It's a little bit tricky sometimes. And now let's cancel what's the same. So I get x plus 4 on top, x minus 3 on the bottom. So that's going to be my simplified expression. But don't forget, then I have to go back and use the entire original denominator and set each of those pieces to say I can't let any of the pieces equal 0. So I can't use an x of 2 and I can't use an x of 3. Again, reemphasizing, you go back to the original denominator. If in the beginning you couldn't use the x value, you can't use it even if it cancels out. All right, next one. So here's some two unique cases of factoring that I want to remind you of. On the top, in order to factor that, well, it's not a quadratic, so we're not going to get two parentheses. If it's something linear, remember, all you can do, sometimes pull out a greatest common factor. In this case, a 4 pulls out of both of those. Don't forget, that's how you factor linear things, all right? And the bottom is that special case. The bottom is that difference of squares, where you get that plus minus relationship, x plus 3, x minus 3, and now I cancel accordingly to be left with 4 over x plus 3 as my simplified expression. And then again, I go back to my original denominator, set both pieces not being able to be 0, so x can't be negative 3, x can't be positive 3. All right, so that's going back into the very, very basics for this. All right, now, of course, we're going to start taking it a step further. So when I'm looking at multiplying two rational expressions, the first thing you want to do is factor everything. All right, factor everything you can in both fractions. All right, then write the restrictions. The reason we're going to do that first is because then you're less likely to forget that you have to use the entire whole denominator. So the reason that we're doing that, again, is so you're not missing any of those restrictions. Then cancel any common factors, even between two fractions, one from the numerator, one from the other denominator. Again, just cancel from anywhere, and then write as a single fraction. All right. So again, first step, I need to factor absolutely everything in here. So I'm just going to start in that top quadrant. The x squared plus x minus 6. That's going to be an x plus 3, x minus 2. That x minus 4 on the bottom can't really cancel, or can't really factor, so I'm just going to leave it. The top of the next one, x squared minus 25. That is another one of those difference of squares patterns. Plus minus relationship, you get x plus 5, x minus 5. And then on the bottom, x squared plus 4x plus 3. Well, that's going to be x plus 3, x plus 1. So again, first step, factor everything, all right? Everything in the problem must be factored. And now it wants us to find the restrictions, all right, before we start canceling anything out. So I'm going to take each piece in the denominator. Each piece in the denominator. So my restrictions are going to be x can't be 5, x can't be negative 3, x can't be negative 1. Those are going to be the restrictions. And again, do that first just to make sure we don't forget any of the original denominator pieces. And now I'm going to go through and I'm going to finish my simplification process. So these x minus 5s cancel. These x plus 3s cancel. And it looks like that's it for my canceling. So it says write it as a single fraction. So I have x minus 2 and x plus 5 left on top. Then I have x plus 1 left on the bottom. And then I'm just going to leave it looking like that. And that's going to be my final answer. Again, each of these has two pieces to your final answer. Simplified version and the restrictions. All right, let's look at our last one for the day. So again, my first goal, factor everything. So that 2x minus 8, again, something linear. All we're going to be able to do is pull out that 2. X squared minus 16. Difference of squares, that plus minus relationship. X plus 4, x minus 4. X squared plus 5x plus 4, we're going to get an x plus 1, x plus 4. X squared plus 8x plus 16, x plus 4, x plus 4. Whew. All right, so now let's go in our denominators and see what is happening with those. So I take each piece. X plus 4 can't be 0. X minus 4 can't be 0. Now I want you to look carefully. Here is another x plus 4 not being able to be 0, but we've already stated that. In fact, same thing here. X plus 4 can't be 0. Well, I've already stated that too. So in this one, if you have repeated excluded values, you only have to write it once. All right? So once you have it written once, you're good, because all that matters is it can't be negative 4 and it can't be 4. It doesn't matter how many pieces there are of those in the denominator. All that matters is that they get stated. All right, and let's do our canceling. So x minus 4 and x plus 4. All right, now again, notice I do have two x plus 4s left, but because they're both in the denominator, I can't do anything about it. All right, so we have 2 and x plus 1 left on top. On the bottom, x plus 4, x plus 4, and that is going to be our reduced expression. You may leave it in factored form. I am fine with that. All right, so today went a lot quicker because, again, this isn't really anything new to you. It's just adding the multiplication piece in. You've already seen all of the factor and cancel methods. So please make sure you have all those written down. Come back to class ready for some practice work.